Okay, this is section 12.2. I want to do this first video with n factorial and permutations, which we've actually seen with the counting principle, we just didn't know it. So let's look at how many ways can 5 students finish in a race for the last cookie. Okay, the counting principle says we got 5 slots. There's 5 ways they can finish first, and now because someone had to finish first, there's only 4 for second, 3 for third, and so on, because this is without replacement. So the way that we solved this was we multiplied. And the way we're multiplying right here, this is the definition of 5 factorial. 5 times 4 times 3 times 2 times 1 is 120. So if you did 6 factorial, you would add a 6 to the list. You just multiply it all the way down to 1. So we want to find this button on our calculator. I'll show you on mine. Well, I'm not going to zoom in, but it's second function on the 3. So second 3. So if I wanted to do 6 second function 3, there's 6 factorial, 720. Hope that showed up. Other people, look under your, remember that PRB button for probability? I think you'll find that as part of it. By definition, 0 factorial is 1, same as 1 factorial is 1. And it's kind of neat. I'm going to do a problem. This isn't in the book. It's like example 1b. So this is like example 1b. I'm going to take and try and figure out 500 factorial divided by 498 factorial. If you hit 500 factorial on your calculator, you'll get an error, guaranteed. Factorial gets so big so fast, there's not enough memory on your calculator. So we have to do it this way. I'm going to start listing out 500 factorial. I'll put the 498 in there. Okay, so what comes next? 498 times 497, all the way down to 1. Well, what's this in parentheses? By definition, that's 498 factorial. Those cancel because they're factors, so we get 500 times 499. And I guess I could do that. 249,500. So just imagine how big 500 factorial is if you're multiplying another string of numbers. Okay, permutations. The big thing with permutations is order matters. So if I said 14 students, how many ways can they select a president Ooh, nice spelling. A VP and a secretary. Okay, so we've imposed an order on these three slots. We got the Pres, the VP, and the secretary. Well, with the 14 students, there's 14 choices here, 13 for VP, 12 here. Yes, this looks suspiciously like the counting principle without replacement, because it really is. It's another way to look at it. 2184. Now I'm going to show you another button on your calculator to do permutations without having to do this, although I tend to favor this because it analyzes the problem for me. So find this button, NPR. On mine it is second function 9. So what we just did, N is the big number, we had 14 students. How many permutations of 3, this is the number of slots that I had, are there? So if I hit 14, second function 9 and 3, it equals, I get the 2184. So find that button on your calculator and practice it. So I'm going to do example 3. In 2015, there's 18 horses. We're entered in the Kentucky Derby. How many different finishes of first through fourth place were possible? So 18 horses. We want first to fourth. I'm going to do it two ways. I'm going to use the counting principle. Because there's 18 for first, it's without replacement. Notice we have the pattern for factorial, but we don't go all the way to 1. And I'm going to do it using NPR. There's 18. We want to know the permutations of 4 for our 4 slots. Either way you do it, you get a few different ways. Okay, maybe I'll do one more problem to finish this video. Let's see. Let me do 38. It's like another election one. Board of Directors, President, Secretary, and Treasurer. So now we want President, Secretary, Treasurer. And how many ways can there be if there are 20 members on the board? Again, I'll do it two ways. I'll do the counting principle. Notice there's an order imposed, so it is permutation. So that's one way to do it. Another way to do it is if you have a total of 20, you want permutations of 3. Six, 8, 40. I'll be straight up. I prefer this method. Only because it works well for me. You can use this, that's fine. But when I do this, I'm using the counting principle and I can see what's going on and I know I'm just multiplying. If I have to think, oh, is it a permutation? Does order matter? What am I doing? Oh man, it's how many out of how many? That's how I get to here. And it's just easier for me to go here. So with permutations, just know that order matters. Practice some of these problems. I'll be back in a bit to do combinations.